Let us start the chapter differentiation. In that exercise 1.2, this is the first lecture on exercise 1.2. The first example is find the derivative of the function y is equal to f of x using the derivative of the inverse function x is equal to f inverse of y in the following. We have not asked to find the derivative of the function directly. What they ask, firstly we have to find its inverse function, then we will find the derivative of the inverse function, and then using the formula to find the derivatives of the inverse function, we will find the derivative of this function, original function. Now what is given? Y is equal to root x. So we have to write the given expression in terms of x. Here y is written in terms of x. Now we have to write x in terms of y. That is called the inverse function. So how to write it? Taking the square on both the sides. So y square is equal to x. So we get x is equal to y square. Now it is a function in terms of y. So f of x is equal to f inverse of y, and that is equal to y square. So this is the inverse function of the given function. Now differentiate this function with respect to y. Then we get dx upon dy is equal to derivative of y square with respect to y. So it is 2y. Derivative of y square with respect to y, so 2y. So, but we have studied one theorem. Dy by dx is equal to 1 upon dx by dy, or dx by dy is equal to 1 upon dy by dx. Use any one of this theorem. So dy by dx is equal to 1 upon, what is the value of dx by dy? It's 2y. Okay, so dy by dx is equal to 1 upon 2 root x. Why 2 root x? Because the value of y is root x. So we will substitute it. We get the derivative of the given function. How we have find the derivative? Using the inverse function. If they have not asked by using the inverse function, then we would have directly differentiate this function with respect to x, and we will get the dy by dx is equal to 1 upon 2 root x. That what we get. Okay, the second function the same type is same. We have to find the inverse function. So given function is y is equal to square root of 2 minus root x. Again we want to find the inverse function, that is y is equal to f of x is given, we have to find its inverse function. So we have to write x is equal to f inverse of y. So how to find it? Now here there is a square root on one side, so we have to take the square on both the sides. Okay, then this y square will come to this side, and this root x will go to that side. We get root x is equal to 2 minus y square. Again there is a square root for x. Again we will square the term. We get this. Now here we have converted, or we have written the given function in terms of y. So x is equal to f inverse of y is 2 minus y square bracket square. Okay. Now we will differentiate this with respect to y. Now how to differentiate? Dx by dy is equal to d by dx of 2 minus y square bracket square. So it is f of y square. Its derivative is 2 times f of y raised to 2 minus 1 into f dash of y. Using that chain rule. Now d by dx of 2 minus y square. Derivative of 2 is 0, and derivative of y square is 2y. Okay. So what you get? 2 into 2 minus y square in bracket minus 2y. Further simplify, you get minus 4y in bracket 2 minus y square. Now here we have to put the value of y using dy by dx is equal to 1 upon dx by dy. So take the reciprocal and put the value of y in this expression. You will get the derivative of the given function with respect to x. Find the derivative of the function y is equal to f of x using the inverse function. Now again y is equal to cube root of root cube root of x minus 2. Now y is given. Now we have to find the function in terms of y. Here there is a cube root, so we have to take the cube on both the sides. So we get x minus 2. Now we will take this minus to that side. So get x is equal to y cube plus 2. This is our inverse function. We will differentiate this with respect to y. Dx by dy is equal to 3y square and derivative of 2 is 0. So using the formula, dy by dx is same as 1 upon dx by dy. So dy by dx is equal to 1 upon 3y square, which is equal to 1 upon 3 model in bracket cube root of x minus 2 bracket square. So this cube root of x minus 2 bracket square can be written as raised to 2 upon 3. The next function is y is equal to log of 2x minus 1. Y is equal to log of 2x minus 1, and here we have to write the x in terms of y. Now how to write the x in terms of y? It is very simple. E raised to y, where the base of log is e. Base of log is e. So we can write this as okay. Now see here how they have written this. So whenever a raised to x is equal to m, then which implies and implied by log of m to the base a is x. This is the definition of the logarithm. So here y is nothing but x, m is nothing but this, and a is nothing but the value e. So if you use that term, you will get the exponential form. Y is x, so here e is a, so here, and this is m, so this is m. Okay, so we got e raised to y is equal to 2x minus 1. So simplify it, you get x is equal to e raised to y plus 1. So what is the inverse function? E raised to y plus 1 upon 2 is the inverse function. Now differentiate this function with respect to y. We get dx by dy is equal to, this is 1 upon 2 is a constant, so we can take outside the derivative. Then d by dy of this first function e raised to y plus d by dy of this 1. So derivative of 1 is 0, and derivative of e raised to y with respect to y is e raised to y. So we get e raised to y upon 2. This is our dx upon dy. But dy by dx is 1 upon dx by dy. So we get dy by dx is equal to 1 upon e raised to y upon 2. After simplifying, you get e2 upon e raised to y. But what is e raised to y? It is 2x minus 1. Put that value here and you will get the derivative of the given function. Now, the fifth example is y is equal to 2x plus 3. It is very simple. It is very easy to write its inverse function. X is equal to y minus 3 upon 2. Differentiate with respect to x. We get, oh no, sorry, we differentiate with respect to y. This 1 upon 2 is constant. Derivative of y is 1 and derivative of 3 is 0. So you get the derivative 1 upon 2. So using the formula dy by dx is equal to 1 upon dx by dy, you can write this as that we get the derivative of y with respect to x is 2. Next, y is equal to e raised to x minus 3. Here this minus 3 will come to this side and we get y minus 3 is equal to e raised to y plus 3 is equal to e raised to x. Now taking logs on both the sides, we get log of y plus 3 is equal to log of e raised to x, but log of e raised to x can be written as x log e, and log e is 1, so we get x only. So x is equal to log of y plus 3. This is the inverse function. So differentiate with respect to y, we get the derivative 1 upon y plus 3, and then we will use the formula of inverse differentiation. Dy by dx is 1 upon dx by dy, because y and x are the inverse functions of each other. So put that value in this equation, and then finally we'll put the value of y plus 3. Y plus 3 is e raised to x. Now y is equal to e raised to 2x minus 3 is the given function. Here also we will take the logs on both the sides and then simplify it. Okay, we get x is equal to log of y plus 3 upon 2. Now this x is equal to f inverse of y is log of y plus 3 upon 2. 1 upon 2 is a constant. We have to differentiate this with respect to y. 1 upon 2 is constant, so we will take outside. Derivative of log of y with respect to y and derivative of 3 with respect to derivative is taken with respect to y. Log of y, its derivative is 1 upon y, and derivative of 3 is 0. So we get dx upon dy is 1 upon 2y. Now using the derivative formula, how to find the derivative of the inverse function, dy by dx is equal to 1 upon dx by dy. We will put the values in this formula. 2, we get 2 e raised to 2x minus 3. Now the next example is y is equal to log of x by 2 to the base 2. Now here base is 2. Whatever the formula I told you last time, now here we have to simplify it and write the function x in terms of y. How to write it? So 2 raised to y is equal to x upon 2, and then find the value of x. Differentiate with respect to y, we get 2 raised to y plus 1. Its derivative is 2 raised to x log x, using that formula 2 raised to y plus 1 log 2. Then use that derivative of the inverse function formula and put the values. And finally we have to convert the answer in terms of x. So again we have to put the value of y in terms of x. Now the second type, find the derivative of the inverse function of the following. Y is equal to x square e raised to x. Now this is some different part. We have to define the derivative of the inverse function of this function with the help of our regular function. Now y is equal to x square e raised to x. Now here we cannot write x in terms of y, so we have to differentiate this function directly with respect to x. Dy by dx is equal to, now here there is a product of two functions, so we will keep a first function as it is into derivative of the second function plus second function as it is into derivative of the first function. Now a derivative of e raised to x is e raised to x, derivative of x square is 2x. For simplifying it, we will take the x and e raised to x common from these two terms. We get ex e raised to x into x plus 2. Now we want to find the derivative of the inverse function and not this function y. Derivative of the inverse function means dx by dy. They want dx by dy. So we have the formula dx by dy is 1 upon dy by dx. Okay, so we'll put the value of this dy by dx in this expression, and thus we obtain the derivative of the inverse function. Now here y is equal to x cos x. So differentiate with respect to x. Dy by dx, again there is a product of two functions, first function as it is into derivative of the second function plus second function as it is into derivative of the first function. So derivative of cos x is minus sin x and derivative of x is 1. So minus x sin x plus cos x. So dy by dx is cos x minus x sin x. Using the formula dx by dy is equal to 1 upon dy by dx, put the derivative of y with respect to x in this formula. This is the derivative of the inverse function. Now find the derivatives of the inverse functions of the following. Y is equal to x 7 raised to x. Differentiate with respect to x. First function as it is, derivative of the second function plus second function as it is, derivative of the first function. Now a raised to x सा derivative का तो a raised to x log a and derivative of x is 1. So dy by dx is 7 raised to x times x log 7 plus 1. Now using the formula dx by dy is equal to 1 upon dy by dx. This dx by dy is the derivative of the inverse function of y. So put the value, we get the derivative of the inverse function. Next function is y is equal to x square plus log x. Directly differentiate with respect to x. dy by dx is d by dx of x square plus d by dx of log x. Now the derivative of x square is 2x and derivative of log x is 1 upon x. So dy by dx is 2x square plus 1 upon x. But we have dx upon dy is equal to 1 upon dy by dx, reciprocal of the derivative. So put that value in this expression and simplify. You get x upon 2x square plus 1 is the derivative of the given function. Next is y is equal to x log x. As usual, what we did in the last example, we will do same. Differentiate with respect to x. X is as it is, that is first function is as it is, derivative of the second function plus second function as it is, derivative of the first. And then simplify, we get the derivative as 1 plus log x. Now dx upon dy is 1 upon dy by dx. So dx upon dy is equal to 1 upon 1 plus log x. We will continue this exercise in our next lecture.